Yo, 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 yo. All right, here we go. 1.5, we're solving inequalities. So a lot of this is going to be familiar to inequalities that you may have learned in the past. Not too much new here today. And so let's just get to it right away. So first thing is inequalities are when we use symbols like less than or greater than, or also when we use symbols like less than or equal to or greater than or equal to. So it's when we're comparing two quantities that are not equivalent to one another, so there's always going to be multiple possible solutions in an inequality. I'll show you what I mean by that, but I guess we'll just talk about it right now. So if I said, like, if I just had the inequalities, the value of x has to be less than 4, that means any number less than 4 is a solution to this inequality. So that means x could possibly be -1, that's less than 4. -10 is less than 4. 3 is less than 4. 3.5 is less than 4. All of these are solutions to this inequality. So there's an infinite amount of solutions actually to this inequality, but it has to be any number that's less than 4. If it's greater than 4, it's no longer possible. There's no longer a solution to this. So one rule with inequalities, and this is the biggest one that people probably mess up on, is when we solve inequalities, if we ever have to multiply or divide both sides by a negative, we have to flip the sign. So write that down if you haven't done so already. But that's the one big rule with inequalities. So whenever we multiply or divide both sides by a negative, we have to flip the sign. Now, let's just start looking at examples and we can kind of go back to some of the little things. So when we solve inequality, they look a lot like equations. They are very similar to equations, except for we have an inequality symbol instead of an equal sign. But we solve it as if it was an equal sign. So the process does not change. So we would solve this problem exactly like we would solve an equation. So I'm going to do distributive property first. I just bring down my inequality symbol instead of an equal sign. It doesn't change anything. I can combine my like terms. I can also subtract 4 from both sides. I'm going to go a little quick because you should know how to solve this if it was an equation. And then I can divide by 18. So for this one, I get x is greater than or equal to 2/3. And the reason I got 2/3 is 12 over 18 simplifies to 2/3. So this is the solution to the inequality. So all the possible values for x that make this a true statement, to make the left side greater than or equal to the right side, all the possible values can be any number that's greater than or equal to 2/3. So I want to show what that means on a number line. Well, if I look at a number line, I have 0, 1, 2, 3. I got -1 over here. So here's my number line that I kind of just zoomed in on this section of it. And I'm working with the number 2/3. Well, 2/3 is between 0 and 1, and 2/3 is right here. So I'm going to put 2/3 right here. And I'll just write down 2/3. And I'm going to work above my number line just so it's easier to see. So there's 2/3, in between 0 and 1. So first, I'm going to plot a dot on 2/3, but I got to determine if it's an open circle or a closed circle. So the closed circle, because anything that has the or equal to symbol means that 2/3 is part of the solution. So I'm going to fill in that circle because 2/3 is included here. So we're filling it in, saying that this is part of my solution because of the or equal to symbol. So I use a closed circle. X is greater than or equal to 2/3. So anything that's greater than 2/3 is also part of the solution. So I want to draw a graph that shows all the possible numbers. Well, we always go greater than when we go to the right. Everything to the right is when we count up. So everything to the right is greater than 2/3. So I'm going to draw an arrow to the right showing that all these values, this is a value at a number line, this is a value, this is a value. All these values are part of this solution. So this shows me x is greater than or equal to 2/3. 2/3 is part of my solution, and everything to the right as well. Now, one thing you can draw to help to determine when you have to use closed circles is you can draw a face here. It's like an angry face, right? Someone that's kind of mad. And then we have the closed circle, we have a solid line. This solid line is actually something we'll use in the second semester in algebra. Okay, so this solid line will be used with or equal to. And then if we have an open circle, we used a dashed line, and that's for when we don't have the or equal to. And that just tells us when we use a closed circle, open circle. These are faces. It doesn't matter which direction you have everything. It looks like a pumpkin, like an angry pumpkin. Okay, but those faces are just to kind of help with Closed circle goes with the or equal to with a solid line. Open circle goes with the not or equal to with a dashed line. And that dashed line will come into play when we graph inequalities later on, different types of inequalities with two variables. And we'll do that in later on. Actually, we'll actually do it in second quarter. So we'll do that later on. Okay? And it doesn't matter which way you have your eyes going. You can do it like this or something like that. Okay? Oh, looks like someone that's sleepy. All right, anyways. So this equation right here, I have the variable on both sides. Doesn't really matter. I'm going to solve it the same way I've always solved equations. So I'm going to subtract 1.5x from both sides. Goes away. I'm left with 2x plus 19 is greater than or equal to negative 7. Subtract 19 on both sides. I'm just going to carry my work over here since I'm out of room. 2x is greater than or equal to negative 26. Whoa, spaz attack. There you go. Negative 26 divided by 2. And then I'm going to get, let's see here, I divided both sides by positive 2, so I'm not flipping my sign. X is greater than or equal to negative 13. Having a negative number is fine. I did not divide both sides by negative 2. I divided them both by positive. So my answer is negative 13. So I'm going to zoom in on the number line at the part that where I'm working with. I'm working on negative 13. So I don't need to start my number line at 0. And then open or close circle, the or equal to symbol. So it's a closed circle on negative 13. X is greater than. Everything to the right of the number line goes up. It gets greater than. So everything to the right is a solution. Okay, try these bottom two and see how you do. Okay, so these ones are kind of more unique scenarios, which is fine. So negative 3x, no, I'm sorry, negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. So I'm left with positive 15 is greater than negative 6x plus 9. Right away we notice that these variables are going to cancel out, and I get 15 is greater than 9. So the question is 15 greater than 9? Is this a true statement? And the answer is yes, 15 is greater than 9. 15 is always greater than 9. So that means that there are infinite solutions, because this is a true statement. 15 is a greater number than 9. So no matter what number I plug in for x, it's always going to be true, where the left side will always be greater than the right side, because 15 is greater than 9. So that means that there are infinite solutions for this one. Another way to say that there's infinite solutions is we could also write our answer as, really, there's all real numbers. So the actual answer is all real numbers for this one, because any real number would make this inequality a true statement. So all real numbers are part of the solution. Now, really, we don't really need to graph that, because every real number is a solution. But if we wanted to show what it could look like, if you think about it, doesn't that mean that we're going in all directions? So you're really just drawing a line going both directions on the number line. And some people we can put the infinity symbol on there as well. That's a 0, not an infinity symbol. Ooh, there we go. Okay. For the second one here, when we distribute, we get 4x minus 6 is greater than 4x minus 5. So right away we should be able to see we have 4x on the same each side. Those cancel. Negative 5 is less than negative 6. Well, negative 5 is less than negative 6. This is not a true statement. So because this is not a true statement, that means that there is no solution to this inequality. There is no number that actually makes this left side less than the right side. So it's impossible to solve, meaning that there is no solution to this particular inequality. Okay, so you got two, graph them, see how you do, pause it, go. Okay, here are your solutions for both. So on the left side, we did have to flip our inequality symbol. So when I solved, I did distributive property, combine like terms, but then I had this negative 1. So because I had negative 1k or just negative k, we can't know, I don't want to know what negative k is, I want to know what positive k is. So I had to divide both sides by a negative. When I divided both sides by a negative, that's where we flip it. So that's why my sign changed directions, and k is greater than or equal to negative 6, which means my graph should look like this with a closed circle. Over here, no flipping necessary. distributive property, combine like terms, move the 15 over, divide, I got 3 over 2 or 1.5. That's an open circle because there's no or equal to symbol. Okay, finally, you will have to do some word problems. Okay, and it's just kind of figure out exactly what maybe the minimum amount of something that we need or the most we can spend or something along those lines. So the unit cost for a piece of fabric is $4.99 per yard, including tax. So $4.99 per yard, including tax. I have $30 to spend on material. How many whole feet of material can I buy? Okay. So if it's $4.99 per yard and it's asking me how many feet can I buy, I want to figure out how much it is per foot. Okay. So first what I have is I have $4.99 per yard. So let's start there. That's $4.99. I could write per yard here if I wanted to. That's fine. So I have $4.99 per yard, and I know I want feet, but what we can actually do is let's solve it for yards, and we can divide by 3 in the end because we know there's 3 feet in a yard. Or I could divide by 3 now, but I don't like the way this is going to divide. So what I know is I have $30 to spend, so that means I cannot spend more than $30. I can spend up to $30, but I can't spend more. So I can spend $4.99 per yard, but I have to spend less than $30 because I can't spend more than $30. So the left side has to be less than or equal to this 30. Now, I know I'm going to get a crazy decimal because of the way the division is, but because it's asking for the whole foot, what I can do is I can say basically it's $5 per yard. Because I don't want decimals. And now when I divide by 5, I figured out that I can buy no more than 6 yards. Okay, I can buy no more than 6 yards. Now I can convert my yards to feet. So because I can buy no more than 6 yards, I can multiply that by 3 to figure out that I can buy no more than 18 feet. But the biggest thing is recognizing that if I have $30 to spend, I have to make sure my inequality is set up so I can buy anything less than that. Okay, but I can't spend more than that $30. Okay, here's your independent practice. We're comparing 2 different companies, company A and B for the florist with their delivery charge and how much they charge per rose. And we want to figure out for what number of flowers it is less expensive to order from florist A or from florist B. So I want to see how you guys do on your own. You can definitely try it out, and then we'll go from there. Okay, get this done. Thanks for watching. Gordias out.